In this video, we're going to go through a factoring review so that we can do a good job when it comes to rational expressions. Our review of factoring trinomials starts with simple trinomial factoring. If a trinomial is in the form x squared plus bx plus c, in other words, that lead coefficient is a 1, then we can attempt to factor by using the sum and product method. We try to think of two values that add to b and multiply to c, and we'll call those values r and s. Then we can say that x squared plus bx plus c equals the quantity of x plus r times the quantity of x plus s. So in example 1, if we needed to factor x squared minus 18x plus 77, then we would want to determine two values that add to negative 18 and multiply to 77. Well, those values are negative 7 and negative 11. Negative 7 plus negative 11 is negative 18. Negative 7 times negative 11 is positive 77. So since the numbers are negative 7 and negative 11, we can say that the trinomial is equal to the quantity of x minus 7 times the quantity of x minus 11. And if we wanted to see proof of that, all we would have to do is expand the trinomial out again. X times x is x squared. X times negative 11 is negative 11x. Negative 7 times x is negative 7x. And then negative 7 times negative 11 is positive 77. These middle two terms add to negative 18x. And we see that we do actually have the correct factors written. That's why the sum and product method works. And so our answer to the question actually being asked us to factor it is this expression x minus 7 quantity times x minus 11 quantity. So what if we have a negative middle coefficient, but our constant term is actually negative? Well, we can still often do that. Two numbers that add to negative 2 and multiply to negative 35 are negative 7 and positive 5. And so we can say that the trinomial given is equal to the quantity x minus 7 times x plus 5. Now, what if both are positive? This is for many students the easiest example. We want to come up with two numbers that add to 5 and multiply to 4. Those numbers are positive 1 and positive 4. So the trinomial given is equal to the expression x plus 1 times the expression x plus 4. And we could also be given a situation with a positive middle coefficient and a negative constant term. And often these trinomials factor as well. The trinomial x squared plus 5x minus 24 equals the quantity of x minus 3 times the quantity of x plus 8. Now this leads us to complex trinomial factoring. If a trinomial is in the form ax squared plus bx plus c, and a does not equal 1, then we can attempt to factor by different methods. And I just want to draw your attention to the difference. In the last example, we were talking about trinomials in the form x squared plus bx plus c, where the lead coefficient was 1. Well, now we're saying that lead coefficient might not be 1, and we might not be able to common factor it out of the expression. Well, there are many ways to do this. Two ways that we'll talk about in this video are decomposition and the crisscross method. With decomposition, we want to find two numbers that multiply to a times c. So we determine what a times c is. Then we come up with two numbers that multiply to that, but add to the middle coefficient of b. And then we decompose the middle term into two terms and factor by grouping. You'll see what we mean with the following examples. We can also use the crisscross method. We can find two numbers that multiply to a and two numbers that multiply to c. Right here it says add. That should actually say multiply. And we find two numbers that multiply to a and two numbers that multiply to c. Then we use the crisscross method, which involves a little bit of trial and error. to find a combination of the values that add to b. And that might not make sense yet, but we'll see some examples coming up. So let's start with an example of decomposition. Suppose we wanted to factor the trinomial 12x squared plus 11x minus 5. We can't common factor the 12 out, so we're left with it. We have a 12 in front. So what we're going to do is take that first coefficient of 12 and that final coefficient of negative 5, multiply them, we get negative 60. Now we want to find two numbers that multiply to negative 60, but they must add to 11 because 11 is the middle coefficient. Well, the two numbers that do that are 15 and negative 4. 15 plus negative 4 is positive 11. 15 times negative 4 is negative 60. Now that we've got that, what we can do is decompose the middle term of positive 11x into positive 15x minus 4x. So 12x squared plus 11x minus 5 is now written 12x squared plus 15x minus 4x minus 5. And that might look counterintuitive at first, but what we do by splitting it apart into those two specific terms, we're then in a position where we can factor by grouping. And if you're not sure what that means, it means this. We have the 12x squared plus 15x. We say to ourselves, well, we can common factor 3x from those two terms. And when we do, we're left with 3x times the quantity of 4x plus 5. And then we look at negative 4x minus 5. We can actually common factor out a negative 1 there. When we do, we're left with negative 1 times the quantity of 4x plus 5. And because we have the same expression in both of those brackets, we can actually factor by grouping. We can say the end result is 3x minus 1 as a quantity times the quantity of 4x plus 5. Now, just to show you why that last statement works, what you could do if you wanted, let's say you were right here and you're a little bit curious, how can we go from here to here? Just imagine we let a be 4x plus 5. Well, if that was the case, then we'd be able to rewrite that expression as 3x times a minus 1 times a. And so we would write it as 3xa minus 1a. Well, we could then certainly common factor out the a. We could do that, and then we would be left with 3x minus 1, as we see here. And then we could sub in back for the a. Well, since the a was in our example equal to 4x plus 5, we would put the 4x plus 5 back in for the a, and we'd still have the 3x minus 1. And so we'd end up with the answer given. Now, you don't have to show that specifically on a test or an assignment. You can simply do the work without showing that substitution step as is shown in the top part of the screen. Now, what if we wanted to try the crisscross method? Well, say for instance we wanted to factor 8x squared minus 14x minus 15. Well, what we could do is come up with two numbers that multiply to 8, and we might try positive 4 and positive 2. And come up with two numbers that multiply to negative 15, we might try negative 5 and positive 3. We don't know if this is the correct order of things, but it's what we're going to try first. Now, what we do is we crisscross and multiply. What does that mean? Well, we multiply the 4 times the 3, as you see here, and when we do that, we get 12. And we multiply the 2 times the negative 5, as we see here, and when we do that, we get negative 10. And now what we do is we add those two numbers of negative 10 and 12, hoping it equals negative 14. Why negative 14? Because that's the coefficient of the middle term. Well, we see it doesn't work. It equals 2. So we didn't come up with the correct combination of numbers. So we simply try it again. Sometimes instead of putting 3 and negative 5, we might try putting negative 5 and positive 3. So what we could do is keep the numbers we have, but literally just switch their positions in the table. Okay? So we, we actually did that. It was -5 and +3. We just changed it to 3 and -5. Now, let's try the crisscross method again. Well, we see 4 times -5 is -20, and 2 times 3 is 6. We're going to add these two numbers, hoping we get the value of -14, which is that middle term, and we do. So this is a very good thing. We have the combination that works. So now what we're going to do is we're going to read across. And at this point, it might help you to think of that 8. That 8 was really 8x squared. So in a sense, that 4 is really a 4x, and that 2 is really a 2x. Instead of thinking of it as 4 times 2 is 8x squared, we could think of it as 4x times 2x is 8x squared. And now we just read across. That 4x and that 3, reading straight across, becomes 4x plus 3. That 2x and that -5 becomes 2x minus 5. And so now we can say that that's our final answer. 8x squared minus 14x minus 15 equals 4x plus 3 quantity times 2x minus 5 quantity. All right, now what if we have a difference of squares? Sometimes a binomial will be in the form a squared minus b squared. If this happens, then we can simply remember a squared minus b squared equals the quantity of a minus b times the quantity of a plus b. So if you want to see proof of that, well, let's just take a look. A times a is a squared. A times positive b is positive ab. Negative b times a is negative ab. And negative b times positive b is negative b squared. If we then collect up like terms, we see these middle terms cancel, and we're just left with a squared minus b squared, which is what we said it would equal. So we see here that difference of squares actually does work. So let's try an example. X squared minus 64. Well, we could think of 64 as being 8 squared. So really what we're being given, instead of a squared minus b squared, we're being given x squared minus 8 squared. That's going to equal x minus 8 times x plus 8. Now, what if we're given 9x squared y to the 4 minus 25b squared? Well, so long as the coefficient is a perfect square, so we've got a coefficient of 9, and we're subtracting because it's a difference of squares, but if you discount the subtraction part of it, our coefficient there is a 25. And we have even exponents, which means every exponent is divisible by 2. If that happens, your instincts might say to you, you know what, I think we might have a difference of squares opportunity here. So what you can do is say to yourself, okay, that 9 has a square root of 3. Instead of x squared y to the 4, let's divide each of those exponents by 2, and we'll call it x to the 1 y squared. And we can say that if we multiply those two together, we would actually get 9x squared y to the 4. So we can actually call 9x squared y to the 4 3xy squared quantity squared. And 25b squared, well, that's like 5b times 5b. And so 5b times 5b is going to be 25b squared, so we can call it minus 5b quantity squared. And now what we have is a squared minus b squared, where the a is equal to 3xy squared and the b is equal to 5b squared. So our answer will be a minus b, in other words, 3xy squared minus 5b, and then a plus b, in other words, 3xy squared plus 5b. Now, sometimes the exponents within a trinomial seem complicated. Well, let's start this discussion with the simplest example of exponents in a trinomial as we've been doing them so far, when we have a situation like x squared plus 8x plus 15. The coefficient of x is 2, the coefficient of the next x is 1, and the coefficient of the last x is 0. When you have a constant term, it's like saying that number times x to the 0. So we have exponents of 2 and 1 and 0 in many of the trinomials we've been given. Well, what if we multiplied each of those? So instead of looking at the exponents, instead of them going from 2 to 1 to 0, what if they went from 4 to 2 to 0? Well, the good news is we can factor that as well. We can also factor if they go from 6 to 3 to 0. Now you might wonder, how can that be? Well, let's look at the 4 to 2 to 0. Sorry, let's go back once and look at the x squared plus 8x plus 15. We would know that two numbers that multiply to 15 but add to 8 are positive 5 and positive 3. So this is what we would get factoring the simple trinomial. Well, if we multiply every one of those exponents of x by 2 and get x to the 4 plus 8x squared plus 15x to the 0, then we would simply multiply each of the exponents of x by 2 in our answer. So instead of x to the 1 plus 5 and x to the 1 plus 3, we'd have x squared plus 5 and x squared plus 3. The factors are the same other than the fact that the exponents have been doubled. But what if we triple all the exponents? So instead of x to the 2, x to the 1, x to the 0, it's x to the 6, x to the 3, x to the 0. Well, since we've tripled all the exponents in the original trinomial, we'll triple the exponents in our answer. So instead of saying x plus 5, x plus 3, we'll say x cubed plus 5, x cubed plus 3. Okay, so that's sort of the method to use when you see you have exponents that don't fall directly into that neat category of exponent of 2, exponent of 1, exponent of 0. The neat thing about this is it actually works in reverse as well. So suppose we wanted to factor x to the 6 plus 8x cubed plus 15y squared. Well, we just saw right here that if you take the y's out of that expression, we can factor that, x to the 3 plus 5 and x to the 3 plus 3. Well, by putting the y's in, if you look, you see they follow the same 2 to 1 to 0 pattern, but they're in reverse. It's 0 to 1 to 2. Okay, well, what do you do when instead of going 2 to 1 to 0, they go 0 to 1 to 2? You say to yourself, okay, instead of beginning each bracket with a term that contains that variable, I'm going to end each bracket with a term that contains that variable. So the x, they descend from 6 to 3 to 0. So like before, we'll begin each bracket with a term containing x to the 3. But since the y's ascend from 0 to 1 to 2, we're going to end each bracket with a term containing a y. So here it is explained in typed form. The exponents on x descend from 6 to 3 to 0, so we begin each bracket with an x cubed term as shown earlier, but the exponents on y ascend from 0 to 1 to 2. This is the pattern of 2 to 1 to 0 in reverse. Therefore, rather than begin each bracket with a y term, we'll end each bracket with a y term. So instead of x cubed plus 5 quantity times x cubed plus 3 quantity, we'll have x cubed plus 5y quantity times x cubed plus 3y quantity. And instead of, if instead of having y to the 0, y to the 1, and y to the 2, if we had y to the 0, y to the 2, and y to the 4, then we would say, hey, we've doubled each of our y exponents. So we would do the same thing in our answer. Instead of ascending, we have 0, 2, and 4. So instead of each bracket ending with a y term, we'll have each bracket ending with a y squared term. Okay? Now, if the above conversation, the conversation we just had, is kind of confusing for you, then the good news is you can just use decomposition. If you're a champion of decomposition, don't worry about all the complicated discussion we just had, because decomposition, one advantage is it actually takes care of all these exponents for you. So, for example, suppose we wanted to factor the trinomial given, x cubed plus 8x, x to the 6 plus 8x cubed y squared plus 15y to the 4. And we say to ourselves, you know what, I didn't get that earlier discussion, but what I'm going to do is I'm going to try and multiply the first and last coefficient. So the first coefficient and the last coefficient multiplied give me 15. And then I'm going to look at the middle coefficient of 8. And what I'm going to do is I'm going to try to come up with two numbers that multiply to 15 but add to 8. And if I do that, I say those numbers are 3 and 5. So I'm going to break apart this middle term of 8x cubed y squared into 3x cubed y squared plus 5x cubed y squared. Now, all I have to do is common factor the first two terms and common factor the next two terms, and then I'll be able to factor by grouping as we saw in our earlier decomposition example. So, seeing what we have here is just a repeat of what was written on the last line. I look at these first two terms and I say, you know what? I can factor out of there x cubed, and I'll be left with x cubed plus 3y squared. And then looking at these last two terms, I say, you know what? I can factor out of there 5y squared, and then I'll be left with x cubed plus 3y squared. And that's what's written here. And notice how, just like in the example earlier with decomposition, we have the same thing written in both brackets. So we can just say our final answer is x cubed plus 5y squared times x cubed plus 3y squared. So let's try this next example here. Using the crisscross method, we're going to look for two numbers that multiply to 6 and two different numbers that multiply to negative 21. I look at the x terms and I say to myself, you know what? These x terms are descending from 4 to 2 to 0. So I'm going to begin each bracket with an x squared term. Instead of 2 to 1 to 0, it's 4 to 2 to 0. So instead of beginning with an x term, I'll begin with an x squared term. I look at the y's and I say, you know what? These y's, they're descending from a y squared to a y to the 1 to a y to the 0. So I'm going to begin each bracket with a y to the 1 term. And then I look at the z's and I say, okay, the z's are doing something sort of funny. They're going from a z to the 0 to a z to the 3 to a z to the 6. That's the reverse. They're ascending, and they seem to be, the exponents seem to be tripled. So instead of ending each bracket with a z term, I will end each bracket with a z cubed term. So if I can remember these statements, begin each bracket with an x squared y term and end each bracket with a z cubed term, then all I need to do is use the crisscross method with a 6 and a negative 21, come up with the middle coefficient of 5, and I'll have it done. So my crisscross method, coming up with two numbers that multiply to 6 and two numbers that multiply to negative 21. It might take a little trial and error, but two numbers that multiply to 6 are 2 and 3. Two numbers that multiply to negative 21 are negative 3 and positive 7. When I crisscross, 2 times 7 is 14. And when I crisscross here, 3 times negative 3 is negative 9. When I add them, I get a positive 5, which is what I wanted. So now I can just directly read across in my next slide. I've got 2 as my first coefficient, negative 3 as my second coefficient, and I remember to begin each bracket with an x squared y term and end each bracket with a z cubed term. And then my second bracket will begin with a coefficient of 3 and end with a coefficient of 7, beginning each bracket with an x squared y term and ending each bracket with a z cubed term. Okay, now if all of that, again, as I said earlier, is kind of confusing, then you just use the method of decomposition. So what you can do is you can take this 6 and this negative 21, multiply them together, get negative 126. Now we're going to look for two numbers that multiply to negative 126 and add to 5, because the middle term is 5. Those two numbers are negative 9 and positive 14. So what we can do then is say that this trinomial with a middle term of 5x squared yz cubed is actually the same as negative 9x squared yz cubed plus 14x squared yz cubed. Okay, and now we can common factor out of the first two terms and common factor out of the next two terms and hope that our brackets are the same. Well, Out of the first two terms, we can common factor out 3x squared y, and we'll be left with a bracket of 2x squared y minus 3z cubed. Out of the next two terms, we can common factor out 7z cubed, and we'll be left with 2x squared y minus 3z cubed. Notice these two brackets have exactly the same expression inside. So that same expression will be represented in one of our brackets, and the other bracket will be 3x squared y plus 7z cubed, and we've factored. Now, what happens when multiple types of factoring apply? Here's a little something to try first. Always try common factoring first. Always try to common factor first. Then, if you see that you can use difference of squares, use it. If there's a trinomial remaining, try using simple trinomial factoring or complex trinomial factoring. And then you might want to use decomposition. It's up to you if the exponents are somewhat complicated. So for instance, suppose you're given the expression shown there. What you can do is right away recognize an opportunity to factor out negative 3xy, leaving it with just x squared plus 6x minus 16. Two numbers that add to 6 but multiply to negative 16 are positive 8 and negative 2, and we can state as our final answer the expression shown. What if we have this expression shown? Well, right away we see we have two terms. We see an opportunity to factor out 5a cubed bc squared, leaving us with 16a squared d to the 4 minus c to the 6. Now, all of these, one of the coefficients is 16 and the other one, discounting the negative sign, is a 1. Both of those are perfect squares, and all of our exponents are even. So that's a pretty good opportunity perhaps to use difference of squares factoring. We see the first term is simply 4ad squared quantity squared, and the second one that's being subtracted is simply c cubed quantity squared. So using difference of squares factoring, we can say it's 480 squared minus c cubed and 480 squared plus c cubed. Now, what if we're given the expression shown here? Well, right away, we might recognize an opportunity to factor out 11abc and be left with 6a to the 4b squared minus a squared bc cubed minus 15c to the 6. And since the a is descending from 4 to 2 to 0 exponent-wise in that trinomial, and the b is descending from 2 to 1 to 0 exponent-wise in that trinomial, we will begin each bracket from that trinomial with an a squared b term. And since the c is ascending from c to the 1 to c to the 0 to c to the 3 to c to the 6, we're going to end each term with a c cubed term. Or we can simply use the method of decomposition, as we've mentioned earlier. That takes care of the exponents for us. Well, however it is that we do that, we see that we can factor this long expression into 2a squared b plus 3c cubed quantity times 3a squared b minus 5c cubed quantity.